Alright, today we're going to look at a tangent graph and what the graph looks like when you do tangents. We know that sine and cosines were sort of the same, just shifted over a little bit, but tangents are quite a bit different. First of all, let's quickly review the unit circle. Remember with the unit circle when we do the coordinate 1, 0, the 0 was our sine, the 1 was our cosine, and then our tangent is the 0 divided by 1. So at this one, our tan of 0 then is 0. If we go to the top, our coordinate is 0, 1. So in this case, if we go 1 divided by 0, so the tan of 90, or pi by 2, is going to be undefined. You can't divide by 0. And if we go back to 180, it would be 0 divided by negative 1, which would be 0. And then at the bottom, we get undefined once again. So,
the custodian for a cleanup outside the main office, thank you.
So these are a little bit weird, but we see that they do repeat. We know that at 45, our tangent is 1. At the next quadrant, we'd get negative 1. Next quadrant, we get positive 1 again. Next quadrant, negative 1, and so on. So we do get some undefined values, which are going to give us asymptotes. Remember, an asymptote line is a line the graph never crosses. And we get then the repetition. So our graph goes from undefined through the 0, through 1 and negative 1, and then it continues to go undefined again. So what happens with these graphs is we end up, let's go back to the title page, we end up getting this type of thing. So we know tan of 0, 0. Tan of 45 is at 1, so that's right about there, pi by 4. Tan of negative 45 would be negative 1. Which is about there, and then the graph just continues. So we end up getting these asymptote lines at pi by 2, and at negative pi by 2, and then they repeat every 180 degrees. So you can see from the graph, tan of 0 is at 0, then we get it at pi, 2 pi, and so on. So we basically, the only thing different with a tangent graph is, it starts at 0, makes these sort of little S-curves, and it repeats every 180 degrees. So because our period is now 180, or pi, remember when you're working with the equation then, our b would be 180 divided by period. Or period would equal 180 or 2 pi divided by b. So we basically do the same thing we did for sine and cosine, but instead of at 360 now, you got to work with 180. Our domain we can see is any real number, and we get asymptote lines every pi by 2, or 90 degrees, and then those repeat every 180 as well. So there we go, we can just kind of look at it. So we got our x-intercept at 0, pi, 2 pi, negative pi, and so on. Our asymptote lines are at negative pi by 2. The next one will be at pi by 2, so they just repeat every 180 as well. The next one will be at 3 pi by 2, and so on. Okay, so you just basically want to remember the pattern, and remember that they repeat every 180 now instead of 360. So when we're doing stretches, everything works kind of the same way, just got to be careful with it. So our regular tan graph then goes from 0, and it's going to repeat at, or the asymptotes lines will be at pi by 2, so let's draw that in. Our next one would be at pi, and that's probably good enough. So we can see now with the transformation, we got a negative out front. So that's going to flip it upside down. So the graph would do the reverse like that. And we've got a 2 times horizontal, which would make it a half. So in this case, then our graph would get switched, half squished. So that means that pi by 2 now would be the next one instead of pi. And the same thing at negative pi by 2. And our last thing is plus 1, so that means we're shifting our graph up 1. So we basically can just move it all up, but let's cheat a little bit. Let's just take this graph and move the y-axis down, or x-axis down, so we're now crossing at the location of 1. Okay, so you get the idea of what the graph would look like. From a tan graph, we can usually see that there's quite a few patterns. So we know that at 2 pi, at pi and 2 pi, we get zeros. We know that at 90 and 270s, we have undefined. And then we know that at 45s, tan is 1, negative 45 would have negative 1, and at pi we'd have 0. So we're just basically repeating these things over and over again. So that's about it for tangent graphs. Pretty straightforward. Just basically remember what the regular tan graph looks like.
Mrs. Cansoni, line 1, please. Mrs. Cansoni, line 1.
Remember that a regular graph goes through the 0, goes through pi, goes through negative pi, and so on. And then you just do your transformations the same. So if you double the horizontal, then obviously it's going to skip and it'll move over to 2 pi instead of pi, and so on. So straightforward graphs, just be careful that they look a little bit different, and other than that, follow the exact same rules we did before.